This playlist collects together and organizes the individual component modules, which together will comprise our first lecture on framing and informal fallacies. In this chapter, as well as the associated lectures, we'll pivot slightly in our orientation in the way that we think about inferences, arguments, and decision making. In the arguments and inferences chapter, we noted that successful arguments combine two components. There's the underlying structural relationships between content elements, described as their logical form, and then there's the content itself. And that a successful argument will have good logical form combined with good content. A successful inference will have a good logical form combined with good initial information. We noticed, however, that our system one, our native, automatic, autonomous inference strategies tend to be driven very strongly by content and tend to be relatively insensitive to underlying structural features. We saw how this results in difficulties in our ability to formulate and evaluate inferences, arguments, and decisions. In this chapter, we're going to look at the other aspect of contextualization, looking at the interplay between logical form, content, and context. We'll talk about how framing, the way in which a problem is presented within a situation, shapes our perception of that problem and makes that problem easier or more difficult to solve, helps us to categorize it correctly or leads us to categorize it incorrectly, helps us to identify important content elements or makes those content elements seem irrelevant or unimportant. We'll see that informal fallacies are arguments that appear to be better, more successful than they actually are. And they achieve this effect through the interplay of underlying logical form, content, and importantly, context. We'll begin the lecture by talking about framing and frame effects, and I'll go through a number of examples to illustrate how the way in which a problem is presented to us can dramatically affect our perception of the problem, make it easier or more difficult for us to solve. Then we'll talk about what fallacies are and differentiate between formal and informal fallacies. And we'll turn our attention to what makes an informal fallacy work. And again, it's here where we'll start to see that it's the interplay between the logical form, the content, and importantly, the context, the framing, the way in which the argument or inference or decision problem is presented to us that plays upon native inference and decision-making strategies in order to make an argument appear better than it actually is when evaluated from a purely logical perspective. For the rest of the lecture, both this lecture and then the lectures that follow, developing our knowledge of various classes of informal fallacies, taking that knowledge and using it to categorize passages as instances of those fallacies or of non-fallacious arguments, rehearsing this to the point where we gain a facility and a reliability that's almost to the point of a perception skill, so that when we see a passage, we are able to identify that passage as an instance of an informal fallacy without engaging in a labor-intensive analysis of the passage that we might normally do when we first learn those concepts. Let's shift our focus now to the three examples that are intended to illustrate how the framing of a problem can make underlying structural features more apparent, can make information more salient, or in contrast, make it more opaque, and in this way, make the problem easier and more difficult for us to understand and to solve. The first example that we're going to look at is an example that we first touched upon in the inferences lecture, the Monty Hall problem. Recall that the goal of the Monty Hall problem is to win as much money as possible by playing repeatedly a game in which, while you're out of the room, I randomly select a box and put a $3 bill inside that box. When you enter the room, I ask you to select a box. Let's say that I put the $5 bill in box number 3 and you select box number 1. I will then take box number 2, reveal that it's empty to you, push box number 3 and box number 1 up, and ask you if you would like to stick with the original choice of box number 1 or if you would rather switch to box number 3. In the alternative scenario, if you select box number 3, the box with the $5 bill in it, I would then again randomly choose between those two empty boxes. Again, let's say I chose box number 2. I reveal to you that that box is empty, I put it aside, I put the remaining 2 boxes forward, and I ask you that same question. Would you like to stick with the original choice, in this case of box number 3, or would you like to switch to box number 1? The question is, what strategy should you employ if you want to win the most money over the long run playing this game repeatedly? The 3 strategies are always switch, never switch, and it doesn't matter. As I noted, when we frame the problem this way, I push 2 boxes up and I ask you to decide whether or not you want to stick with one or choose the other. The vast majority of people will say that C, it doesn't matter. There are 2 boxes, the $5 bills, in one of them, there's a 50-50 chance I'm going to get that $5 bill. In fact, as we noted in the inference chapter, you should always switch. The real choice that you make is the choice between the box you originally chose and the contents of the other 2 boxes. I merely make an elaborate show, a presentation. I frame the reveal, as it were, in such a way that you appear to be choosing between 2 boxes in the end, when in fact you are always choosing between the original box and the other 2. We noted that if you frame this Monty Hall problem in an alternative fashion, it becomes much less difficult to see the appropriate choice strategy. So for instance, no matter which box you choose, if you do not switch 1/3 of the time, you will get that $5 bill. If you switch, no matter which box you choose, you will get that $5 bill 2/3 of the time. And when we present the problem in this framework, the underlying structural relationships are more obvious, and it becomes easier for us to see what the appropriate strategy choice should be. Let's consider a problem we haven't looked at before. This is called the Buddhist monk problem. A monk sets out at sunrise to visit a temple at the top of a mountain. He walks all day, taking breaks of various lengths randomly throughout the day. He arrives at sunset, spends the day, and sets out for the base of the mountain the next morning. Again, he walks all day, taking breaks of various lengths randomly throughout the day, arriving at the foot of the mountain at sunset. Is there some point on the mountain that the monk reached at the same time of day on both trips? And when you present this problem to people, they usually don't have a clear idea about what the answer might be. Presented as a vignette, it doesn't suggest the underlying structural features that would dictate the answer. If, however, you present it as a graph, the answer becomes deucedly obvious. If our solid line is his ascent and our dotted line is his descent, we realize that at some point those lines will cross, and that will be the same place at the same time on ascent and descent. The problem becomes relatively easy when framed that way. We'll do one last example of this to illustrate our point, and this comes from perception of brightness. So if I show you these objects here in this computer-generated image, and you look at those 2 objects and I ask you which is darker, A or B, overwhelmingly people are going to tell you that A is definitely darker. If I introduce this mask over those 2 sections, however, that overwhelming choice disappears. The 2 sides look similar. Why is this possible? How is this possible? Well, in the first instance, our picture is framed in such a way as to make it look as though there are 2 surfaces, one that is angled downward out of the light and one that is angled upward towards the light. A light is shining down on surface A and it's masked on surface B. Since they have the same reflectance, our brain then makes an interpretation of that context, and it infers, based on its interpretation, the contextual cues that it has in that image, that A must be much darker because its reflectance is the same value as B when it's got direct light on it and B does not. So framing, how it is that a situation presents a problem to us, can highlight features, structural features, content features, relationships, properties that make a problem easier to understand, easier to solve, or that make a problem more difficult to understand and more difficult to solve.